Hi, we're here to talk about Aspen Inmation. We described our solution as one system, zero bottlenecks. It's the Inmation data fabric for Enterprise B. My name is Ryan Halleck. I'm a product manager for Aspen Inmation product.
And I'm Dave Weiler-Thiessen. I'm a data and software specialist with Spartan Controls, and we're an integrator for Inmation. Go ahead, Ryan.
Okay, so our demonstration, just to set the stage, right? We're running a presentation and some of our live tools. Presentation above, live system below the demonstration. So this is a completely live demonstration. We're connected to the ProveIt virtual factory. Enterprise B is our focus again. Big picture here is this is one platform. This is a single software. We didn't use anything else but Aspen Inmation. We say unlimited integration. So this is vertical, horizontal, scalable solution, one single solution. So off the top, we're going to answer the 4 ProveIt questions. So the remaining time we can go through the demo. We will spend a little bit of time explaining some of the high level, let's say, Aspen Inmation in a nutshell, explain some of our main components, and then we'll go ahead and start explaining our solution, what we did here today. So the problem we solve with our software and here at ProveIt is basically this technical complexity of system integration, right? So we've seen some of the other solutions, for example, or we've lived this in our own system integrator life, right? You have disjointed data sources, hard to get at data. We're using whatever tools and technologies we can get our hands on, often building a kind of bespoke data chain, right? Aspen Inmation is about replacing that with a single, mature product, right? This is about not stalling those IoT initiatives, right? We can all do that student project, we can do the POC, but how does it live in the real world, right? Customers want to have a kind of unified data strategy. Do they have a software to support that unified data strategy? A unified software approach, right? Sometimes they do, might be a collection of software, but we also think about minimizing that vendor footprint for our customers. That's something they're also interested in. So our solution, I'll go to how we solved it. So our solution is the Aspen Inmation data fabric, right? It's the primary enabler for this digitization journey, which we find our customers on different stages. I like to call it a software-defined infrastructure, right? There's a lot we can talk about with Inmation, but at its essence, we think about a software-defined infrastructure. So actually deploying this single piece of software, one single system, to achieve all that data collection, ingestion, historization, or we can say persistence of data. We can augment data. We essentially have a unified namespace inside of our product. So we're not only persisting data, we're persisting all the objects and what we call model trees that you'll see David present. Those are all persisted, right? So we are egressing that as per the challenge requirements to the UNS here with MQTT, but we could also view that model tree or those objects in OPC, or we could access our RESTful web API and see those same objects expressed, right? This persistence is an important piece. Yeah, security built in, very stable. We care about data integrity, right? That's often overlooked with point-to-point solutions or sort of, it's like quickly sort of cobbled together or stick-built solutions, right? How's that gonna hold up over a month? How many outages do you have over a year? That's all built into Inmation. Okay. Dave will talk about our solution, like the mechanics of it, the data flows, pretty soon. So how long did it take? We're saying about 50 hours of our effort. So honestly, we were a little bit crunched for time. We were a late joiner. We spent about 50 hours setting up the solution you'll see today. And a license cost of about $50,000 US. Okay, so just one short stop. What's Inmation, right? So for me, It's really about decoupling data acquisition or data sources from use cases or data consumers. We want to create this middle one source of truth, right? Data set representing your virtual factory in this case, right? And then scaling out use cases is that much more efficient, right? The overhead is lower. The data consumers or the humans that actually do data analysis, for example, or process optimization or alarm management, they come to trust such a system and not worry about the mechanics behind accessing that data. So it's kind of like a fundamental plumbing we put in place to enable data analytics, AI, right? Everyone's buzzing about AI. We need good quality data. We need data in context for AI, right? This is critical if we're going to do this. And this is also about doing any of these initiatives at scale. So of course, you have a one-off use case. You have a very small production facility. Inmation can do a great job. But when you scale that out to 20 sites, 50 sites, hundreds of discrete process units, right? That's where this kind of solution starts really, the benefits start being amplified. Yeah, we won't dwell too long. So if I could just highlight 9 of the core features that I often try to fill people's ear with, right? So an important fact is that the components I'll introduce on the upcoming slide, they're all a single EXE. That's named Inmation EXE. So Inmation EXE expresses itself as a connector, or Inmation EXE expresses itself as a core. But this is essentially a 50 megabytes executable. We can install it from command line. We also have a MSI installer, right? I won't get too deep into that. But it's really, for me, a very elegant design and shows a cohesiveness in that this solution was designed from the ground up with this vision, right? We have the autonomous functionality of the distributed components. So we'll get into the components later, but these components are expected to run in case of network outages or a parent somehow dies or burns down, right? So this is built into this software, autonomous operation. If we architect a solution for something to run autonomously in a certain network segment, it will run autonomously. The installation, this is a modern, very robust, very resilient in terms of OS compatibility. The installation is a low overhead. I mentioned the command line installer possibility. We have also like an infrastructure as code possibility for installation and deployments. And if you imagine a sort of big network of microservices of all our components in a typical architecture, we have the possibility to do what we call automatic upgrade, right? So we can update a high-level component and have that update propagate through the entire system. So you don't have to, generally speaking with Inmation, you do not have to visit those host systems outside of the initial deployment of a service, for example. Data integrity, right? So guaranteed real-time data delivery. We have store and forward buffers on every component. We have data historization capability. Some people really focus on that. For us, it's just another feature. It's optional. We're using it today. We have inbuilt monitoring we call generally performance counters. We have a few of those displayed on this lower screen. So those are live performance counters just showing the CPU. We can see memory usage, but we can see our own internal like send rates if those buffers are growing. There's a wealth of information in our system monitoring, which is very important when you build a large scale system. And problems in the network, problems with underlying data sources, you need to be able to investigate those also ad hoc and look back, right? So we can archive those performance metrics. Very important feature in the bottom left is the basically internal Lua API. So we can extend this system from inside. We can run logic. We can create and attach libraries at different levels of our system. So we're also leveraging that in our solution today. Some of the built-in automation, specifically, right, that we can receive data from sources and eventually dynamically create ISA 95 model tree of assets based on the dynamic data incoming. We're very use case and vendor agnostic. You heard me kind of mentioning that. We want to decouple use cases, right? So is it energy monitoring? Is it an audit log, audit viewer? Is it a MES interface, right? These are all separate use cases for us. We're agnostic. And yeah, sort of very important point, which we did with the SM profile and the ProveIt challenge, but whether we're pushing data or data consumers come to our web API to pull data, we take the approach that we're able to adapt to those consumers. So that's very normal for us, like this SM profile, to get the requirements that I need data like such and such. So data consumers do not need to adapt to the way we present data. Okay, so now I just want to briefly run through, Dave, maybe we, or no, that's fine.
Sure.
So this is actually a live, what we call Web Studio display. This is on board our Web API component. So this is running live on our system. And on my presentation, I just want to walk you through some of the components. So connector might be obvious, right? This is our component, kind of our edge component that's designed to sit as close as possible, in our opinion, to the data sources. Because anytime you see a blue line, we kind of guarantee that delivery of data. That's our data. We're responsible for that. But if you see a black line, whether it's MQTT or a red line, what's OPC, we don't control that. So we want to minimize those non-emission lines in a typical architecture. So we want to deploy those connectors. We can deploy redundant connectors, right? So the workhorse of Inmation is a core.
Where are we going?
Sorry, I skipped over the relay. We're not using a relay. This is a very lightweight component so that we don't need to rely on IT solutions to, for example, bridge a DMZ, a DMZ in the United States. We can use it as a component that we can monitor as well and not have to rely on some IT solutions to bridge network layers. We didn't need it for the ProveIt challenge. The core is the workhorse. In this case, we're also using local cores. You can see there's a core here, lower, and a core above. This is a typical construction. So why we don't just pipe a connector to a core, let's say a cloud core, well, we can do that, but the local core gives us data historization at that level. It gives us the ability to access that system with our data studio at that level. We can also hook up a web API and or a OPC server to that component at that level. So it offers us a lot more flexibility. So the central core is somewhat indistinguishable from a local core, except that it does host our log, and there's no parent to a master core. In the ProveIt solution, what's shown here, we also have the MongoDB repository there, living beside that core. It can also be on separate systems. It's fine. And of course, this endpoint data server that's just shown as one system, but those components are actually distributable as well. Every component on this slide is distributable. We architect a solution and decide where to place these components. I touched on it already. This very powerful web API with a web UI builder on board and an OPC Classic and OPC UA interface we call server. Okay, so here we have those components represented how we built the solution for ProveIt, right? So we have a master core, 3 local cores, and many connectors. Just to sort of explain this, what we call Web Studio display, right? It's just showing, visualizing some of these data flows, right? But I think at this point,
Sure.
we can dive a bit deeper into our solution,
Sure.
right? And show some of our tooling.
Sure, let's do that. Sure, thanks, Ryan. Yeah, so what we're showing here is, so we've got the multiple sites. We're doing Enterprise B, and we focused on the filling production area. And in that area, in the virtual factory, there was information about the current work order that was being produced and the amount of bottles that were being bottled. And so what we decided to do is, instead of waiting for the end of the production run to report that information to an ERP or some other business network system, we thought we would capture that data within Inmation and then produce hourly updates of that information to other business consumers of that data. So what I'll do next now is I'll flip over to Data Studio and talk about the flows that we've got. So if you want to advance the next slide there, Ryan. Thank you. So then the dashboard that I'm showing down here, this is just showing how we're actually able to bring in those live updating values from the virtual factory, and we're historizing that data. So if I open up this display over here.
And sorry for a short interruption, but you'll see that this system is actually using the OPC UA interface, and it goes down from time to time. So you can see it's live by the fact that it goes down, and if someone pays attention, you see that it may turn green and we'll get some signals coming in.
Yeah, that's right, Yeah, no, that's all good. No, thank you. Yeah, so within our solution, we're doing MQTT from our Dallas site as well as from our El Paso site, and as Ryan was saying, from our Houston site, we're doing an OPC UA connection to bring that data in. And yeah, based on how the virtual factory is working here, it's been a little flaky today. So we're seeing is it red right now, but hopefully it'll go green during the demonstration. So what we're doing is we're trying to leverage InMation as a middleware solution, and not all organizations are set up with like modern 4.0, industry 4.0 technology. And so so even though we're reading the data from the virtual factory, UNS, we're actually pretending that we're connecting to a legacy system. And so that's where we're bringing in some of these tags and providing that type of context here within the solution and historizing that data. So that's the first stage in our data flow that we're implementing. So Ryan, if we want to maybe advance the slide. So there, yeah, let's stop there. So I'll flip over here to our stage 2 dashboard here. And so what we do is we've used the connectors to bring the information into InMation. The information flows up through the network up to the core, and then persists the data inside of Mongo. And then what we've done from a data processing perspective is we're leveraging an event-driven architecture solution to send work requests from the local site up to the master core to do processing. So if I look at this message here, so this is internal to the solution here, where we're sending off a processing event that's going to go up to the core to do processing on the data. So this is where we're going to look at the process or the work order numbers and the quantities for a given hour that's been requested, and process or create that into a production declaration message. So if we advance the slide, so this is where we're sending that information up to the master core. And again, the reason that we have to send that to the master core is because that's where our persistence is. So again, we can orchestrate and move information around within the platform to execute the processing that we want. Then if I look at one of these boxes over here, this is the generated production declaration message that we're creating, and we're publishing this into the virtual factory UNS. And so we can see here, for that particular work order, that was the quantity of product that was produced within the hour that we requested it for. So now that's showing that we were able to bring information from, let's say, a brownfield non-4.0 system and do some processing on that value add and send that off to the UNS. So now again, acting as middleware, we can do the opposite type of integration, where we bring information from the unified namespace, bring it back into InMation, and then send it out to a legacy system. So if I flip over here to our stage 3, and then again, if I just look in the I/O model here, you know, we've brought in the data here using another MQTT data source. Again, we're following the tree like you see in the unified namespace. And again, we're just subscribing to our own message that we're publishing. So again, this is the most recent or live data that we published to the UNS. We're bringing that information back in. And then, oh yeah, let me talk to that a bit more. So here, with unified namespace, might not be that easy to see, but because we've got that path, there's a lot of context information in there, but we're going to send this information to a legacy system that won't naturally have that context. And so what we've done is we've created an equipment model where, again, the equipment model mimics the the unified namespace for Enterprise B. And on the Work Center object, if I bring this open here, we've been able to go in and customize and add metadata to that object there. And so that provides us machine identity information, which we will then use to republish as a machine identity SM profile. So if I go hide some of my windows here. So if we go look at this last box down here and drill in a little bit. So this is our augmented message that we're sending to our legacy ERP system. So again, we've just taken that production declaration message, embedded that within the document. We provided some context information by the equipment path, which then that external system could come back and query that information from us. And here's the machine identity, the extra metadata that we're sending along to that external system. So that is the use case that we built. And so again, we've set up where we can talk brownfield to modern 4.0 and then 4.0 again back to a brownfield legacy system. Over to you, Ryan.
Oh,
I'm sorry, yeah.
right. We showed this, yeah?
We did show that, yep.
Okay, sorry.
That's all right. There you go.
Can we show the Web Studio display?
Yeah, sure. Let's go back to
the other one, right?
Yeah, you betcha.
This one, please.
Oh, yeah, that's right.
I think, right?
Yep, that's right.
So I think we're just showing off a little bit on the Web Studio display, a kind of mock-up of something else we could build, and in our UI, it's not part of the challenge. We just want to run through a few bullet points to wrap up, right? Or in a summary. So we talk about, again, like probably said it 5 times, but it's a single system. So shop floor to cloud, right? It's the same system, just about architecting which components to put where. And then of course, the work to, build those data flows, right? This is an enterprise scale solution. So we have about 100 plus customers. This is about 10 plus year old product, right? We have some very large multinational customers with global, let's say geographically disparate sites, so global systems. This is all running for many years in several of those implementations. Here we talk about data streams or handling data in the millions. So we hear numbers like 15,000, 20,000. These are like a little bit POC numbers for us, right? So whether sort of a simple use case example would be maybe historian to cloud transfer. Well, what's that sort of initiative name or the use case? We could call it OT data lake, right? So maybe that's 10 historians from Honeywell, from Aviva, from Aspen Tech. We have native connectivity to all those, and we need to constantly populate this OT data lake. Just an example. You can imagine the kind of numbers that are involved when we're moving this kind of data. Data type agnostic, right? I talked about native historian connectivity. We have some native Siemens or other control system connectivity, right? MQTT, which we demonstrate here, the OPC flavors, Kafka, Modbus, etc. We're trying to expand that as well. Just to sort of hammer on it again, we are essentially a UNS ourselves. In the ProveIt challenge, we've showed that we can populate the UNS, no problem. Also with the SM profile, let's say style of data, yeah. But you can also treat information as a UNS in and of itself. The data itself can be persisted, like historizing data, but these objects and these model trees also exist, yeah, once we create them. We're actually quite deep into life science with a lot of our customers. We kind of found a lot of features or a lot of the capabilities of information were well suited for life science. So that's quite notable because, besides the audits we undergo, it really has been quite a test for our software to be in those validated industries. We can't take any shortcuts. We can't lose data. We need audits. We need audit trail. We need to have, full visibility, or we can't play in that space. I mentioned our sort of vintage, right? So it's relatively modern, but 10 years is enough to call us mature. And the founders of Inmation, the vision that created this product, right? We had a history in the OPC technology. So we actually, you make good money in engineering services and maybe also selling those components. We kind of bled over a lot of those projects, right? And what we really saw was that customers were in sort of the maintenance phase, run and maintain phase, that they were struggling to maintain this web, this matrix of, tunnelers and buffers and security gateways or redundancy managers. Yeah. And then you add the new emerging protocols to the picture, and this kind of vision for Inmation start to take shape. In our opinion, we proved it. We're interested to see the other presentations, but we're not sure anyone else has some of the capabilities that we have.